So in today's lecture, we are going to discuss the equation of motion, right? Equations of motion. We have the three equation of motion, as you know, right? All these equations are valid only for if acceleration is constant. That is, if a car starts moving, right, with the initial velocity is u, with the constant acceleration, and after time t, right, it is the situation at t is equal to 0, and after time t is equal to t, it travel the distance or the displacement s, and its velocity become v. Is it clear or not? So the situation is that the acceleration is constant, mean the acceleration is written as dv upon dt. It is constant, right? A is equal to what? Constant. So you may write dv is equal to a into dt. If you integrate, right, this is the integration, right? The integration of v is what? Say dv. The a comes out from the integration because it is constant. Inside it is remains only dt, right? So dt integration is what? T. Also, listen one thing. At t is equal to 0, the initial velocity is u. At t is equal to t, at t is equal to t, the velocity become v. So what are the limit? From u to v, and the time varies from 0 to t. When you will put upper limit minus lower limit is equal to a, then upper limit minus, right, lower limit. Is it clear or not? So v minus u is equal to a into t. So this is the equation v is equal to u plus at, right? The first equation of motion. This is called the first equation of motion, right? What is u? U is nothing but, you may write initial velocity, right? What is v? Is the final velocity. A is the acceleration, t is the time, right? Copy this. So this is the first equation of motion, right? The second equation of motion, right? Second equation, if v is equal to u plus at, so you may write it is the dx upon dt, right? Or the velocity at any time t, right, may be written as ds upon dt is equal to u plus a into t. So if you multiply u plus a into t dt, is it clear? So this ds is the elemental displacement. If you integrate both sides, right, at t is equal to 0, the displacement is over here is what? 0. At t is equal to, the displacement become s. T is equal to 0, it is 0. At t is equal to t, the displacement become s, right? So here the s minus 0, right? The differential integration of ds is what? S, and the limit from 0 to s, u into t. The differentiation of 1, the integration of 1 is t plus a. The integration of t is t square by 2 from 0 to t, right? Then put upper limit minus lower limit. Then first put upper limit half a t square, then put minus lower limit, right? So s is equal to ut plus half at square. So this is the second equation of motion. Second equation of motion, right? Copy this. So the third equation of motion, how to solve that? This is v, right, is equal to u plus at. This is the first equation of motion. Square both side. If you square both side, u plus at whole square, fine, and therefore the v square is equal to what? U square plus a square t square plus 2ua into t. Is it clear? So listen one thing, this is the v square, and v square is equal to u square plus, fine, and if you take the 2a common, right, or here you can write, listen one thing, right, this is the ut, right? If you multiply by 2a both side, so 2as is equal to ut plus half at square. Is it clear? This is the second equation. If you multiply 2a both side, then it become 2uat plus a square t square. Is it clear or not? So 2as. So 2uat plus a square t square is equal to what? Say you may write 2as. This is nothing but 2as. So v square is equal to u square plus 2as. This is the third equation of, right, third equation of motion. Is it fine? Listen one thing. Although these are equation of motion, out of these, the first and the second equation of motion is written as vector v is equal to vector u plus vector a into t, because u velocity and the acceleration are vector. In the same way, s is the displacement, this is the displacement, u is the vector quantity, and acceleration half t square. While these two equations are the vector equation. Vector equation mean it gives the velocity, right? It is what? Say velocity, and it gives the displacement. Is it clear or not? But the third equation of motion is written as v square is called u square plus 2a dot s, right? The square of any quantity is always scalar, and a dot s, this is the dot product of the two vector quantity, it is also a scalar. So scalar plus scalar is equal to scalar. Here vector plus vector is equal to vector. So this is the scalar equation, and this, from this equation you will get always the speed. Is it clear? So these are the vector equation and this is the scalar equation. You must remember in your mind, right? Copy this. Third equation mean this is the v square is equal to u square plus 2as, right? Since the acceleration is a vector quantity and the displacement is a vector quantity, so generally it is written as a dot s. This is the 2a dot s, right? This is the form of the equation. You can write as of now, right? When we will solve the question, then you will understand how to put the value of the u, a, and right acceleration and v. Right, when we will solve the question, you will understand all the symbol and the right why it is vector and what is the meaning of the scalar over here. Please copy this as it is. Okay, so read this question. In this question we have the two car. Start A, suppose A, and this is the car B, right, with the velocity. Initial velocity is 2 meter per second and this is the 4 meter per second. So whose velocity is more? The car B has the big velocity as compared to A with the uniform acceleration, but its acceleration is what? 2 meter per second square. Fine. And its acceleration is what? Say 1 meter per second square. Mean acceleration mean its speed is increasing fast, but its speed, initial speed is more, but it is increasing right less. So when the at t is equal to 0, they start its motion. Initially the car B will move fast, right, and the car A will lag behind with this. Why? Because its initial speed is less, but the speed of this car is increasing at a fast rate, 2 meter per second per second. It is increasing 1 meter per second per second. So what will happen? It will continue to move. At some time the car A and the car B again will be at the same point. Is it clear or not? Then what is the length? They are asking the length. Is it clear? So we can apply for car A, right? S is equal to ut plus half at square. You can apply. What is the displacement? Suppose the displacement is s. The initial velocity, right? I am writing the u. The time we don't know. The acceleration is 2 into t square. For car A I am writing s is equal to 2t plus t square. In the same way for car B, right? Suppose the time after time t, at t is equal to 0, they start right from the same position, and after time t, right, both right are at the same position, right? So for the car B, again you can apply s is equal to ut plus half at square. What is the displacement? Say s. The initial speed is 4, the time is t, half, the acceleration is 1 into t square. So s is equal to 4t plus half t square. Is it clear or not? Now both displacement in time t for car A and for car B, this is the displacement, are same. So what is the condition? Condition is that after time t the displacement of A and displacement of B are equal. So therefore 2t plus t square must be equal to 4t plus half t square, right? So 1 tt will cancel out, 2 plus t is equal to 4 plus t by 2, right? So this is t, if you simplify 4 minus 2, so this is equal to 2, so t by 2, so t is equal to 4 second. So if you simplify this relation, so t is equal to 4 second, that is after at t is equal to 0 they are at the same position, and after time t is equal to 4 second both are again at the same position. So at t is equal to 4 second you have to find, either you can find this, right? This is the displacement as a function of time t. So what is the displacement of car A after 4 second, right? This is 8 plus 16, it is 24 meter. Or you can put 4 into 4 plus half into 4 square, right? This is the t square. 16 plus 8 is equal to 24 meter. So what is the distance or the displacement covered by both the car is 24 meter. Either you can use this equation or you can use this equation. So this is the path length covered by the both car, right, when they meet again after 4 seconds is 24 meter, right? Copy this. So read this question. It is a very good question and has been asked in, right, examination also. Particle move in a straight line with uniform acceleration. Suppose this is the car. The initial velocity of the particle is what, supposed to 0, and the acceleration is constant. So after time t what will happen, you tell. After time t the velocity become, it is t is equal to 0 at t is equal to t. So the distance will be over there, right? Find the average velocity of the particle in initially first distance. Can you tell me what is the definition of the average velocity? Average velocity is nothing but total displacement divided by total time. Is it clear? So this is the average velocity, and what is the total displacement you will write? You will apply the second equation of motion. S is equal to ut plus half at square. The initial velocity is what? Say 0 half into t square into s. So 2s upon a is equal to t square. So t is equal to what? Root 2s upon a. This is the total time. Are you getting? So what is the average velocity? Total distance divided by total time. Fine. When you will simplify this, right, this is s root a upon 2s, right? So it may be written as when s goes inside, s square into a upon 2s. Fine. This is the 2s. S will cancel out. So square root half a into s. This is the average velocity in terms of, right, acceleration and s. Right. If this is the x, right, and this is 3 suppose. So when it goes inside the square, inside the square root, it become x square. You understand or not? So when it comes out from the square, it become what? Say x root 3. So therefore, if it is s, so 2s, this a goes in the numerator. So when this s goes inside the square root, so it become s square. A upon 2s, one s is cancel out. So sa, you may write it is the sa by 2, right, is the average velocity. Is it clear or not, you tell? Copy this. But listen, the question, in the question the displacement s is given, so we have to find the answer in terms of s, right? If it said that the in time t find the average velocity, then definitely s is equal to half at square can be put, half at square upon t. So tt will cancel out, a, right, half, right, at will be the average velocity in terms of t. But in the question the acceleration and the displacement is given, so that is why we have replaced the time t in place of, right, in terms of s we have replaced the t. You understand or not? If it was given the time t, suppose in time find the average velocity for the initial time t, so then we have to give this answer, right? Copy this. So read this question. This is the important question. Suppose this is the train, right? Suppose this is the train like this, right? And the train is moving initially with the speed 20 kilometer per hour, right? And there is a pole, right? There is a pole. Suppose there is a pole right over here, and how much away it is? Say 2 kilometer. Fine, this is the 2 kilometer away from this. Is it clear or not? Right? And there is a bird. There is a bird over here. So now, if it is retarded, the acceleration is produced. That is, the retardation is produced, and the uniform deceleration. We don't know the acceleration, so the acceleration is over there, right? Brake apply, unit the bird fly after touching. So what is happening? Its speed continuously decreasing. I'm making this, right? Its speed is what? Continuously, it is u is equal to 20 kilometer per hour. So after some time, when the brakes are applied, the speed will reduce or not, right? It will reduce. So after some time, its speed decreasing. So what happened? At t is equal to 0, it is at 2 kilometer. At t is equal to 0, this is the bird. So it start, right? It start and it move towards the train. It touch the train, right? What is the velocity? The velocity of the bird is what? 60 kilometer per hour. You understand or not? Although this is moving, right, in a straight line. Fine. And when this train reaches to this point, this bird touch the train and fly back to the pole. Are you getting? Meanwhile, this train is moving forward continuously, but the speed is what? Decreasing. Then it touch the train, right, and move again. Is it clear or not, you tell? Bird is coming, train is also going towards the bird. So bird touch the train, go to the pole. Touch the train, go to the pole. By what velocity? By what velocity the bird is flying? Say 60 kilometer per hour. 60 kilometer per hour. You understand or not? So again, so before stop, how much distance is covered by this? This is the distance S. This is the distance covered by the bird. You have to find. Is it clear or not? So you tell me, what is the what is the time? This is the initial speed, right? And what is the displacement? Displacement is S. Is it clear? So V square is equal to U square plus 2AS. The initial velocity I am writing in 20 kilometer per hour. Is it clear? Plus we don't know the acceleration, and after traveling the 2 kilometer, right, the brakes are nearest continue train stop. Calculate how much distance the bird cover, train stop. So when the train stopped reaching to this point, the speed become what? 0, and the displacement is what? Say 2 kilometer. So this is 400 plus 4a. So 4a is equal to minus 400. So acceleration is minus 100 kilometer per hour square. This is the acceleration is in negative, that is, it is retardation. Its speed is continuously decreasing. Is it clear or not, you tell? Vranda, the unit is understood. It is in kilometer per hour because the speed is kilometer per hour and also distance is in kilometer. So the acceleration is in kilometer per hour square, right? So this is the u, this is the v. How much time it take? V is equal to u plus a into t. So when the train reaches to this pole, the speed become what? Say 0. The initial speed is 20. The acceleration we have found, and the time. So 100 t is equal to 50, 20. T is equal to what? Upon 100 is equal to 1.1 by 5 hour. So how much time it take to reach from? Yes, 1 by 5 hour. And in this time, the bird is continuously moving, right? Bird is continuously moving with the speed 60 kilometer per hour. So for bird, what is the velocity by which it is moving continuously? 60 kilometer per hour. How much time it moves? say 1.5 hour. Are you getting or not? So what is the total distance? Therefore, S is equal to Vt, right? Or in class 9th, you have learned the distance is equal to speed into time. So by what speed it is moving? Say 60. How much time it moves? 1 by 5 hour. So this is 12 kilometer. So the total distance covered by the bird, this distance, this distance, this distance, right? Total 12 kilometer distance is covered by the bird. You understand this question, Vrinda? Right, copy this. Now the next topic, important concept, is the distance covered in nth second. Distance covered in nth second, right? Distance covered in nth second, right? What is the distance covered in nth second? For example, I'm giving you an illustration. Suppose the speed is 10 meter per second, fine, at t is equal to 0. All right, so this is the speed is continuously increasing. Suppose the acceleration is what, say 2 meter per second square. Is it clear? So this is the t is equal to 3 second, right? And after some time the time become t is equal to 4 second. Are you getting or not? So can you find the distance travel in 3 second? Right, we can find. Can you find the distance travel in 4 second? Yes, we can find. How to find? S is equal to ut plus half at square. For t is equal to 3 second, the distance travel is, right, as 3. U is what, 10. What the time you will take? Say 3 plus half 2 into 3 square. 30 plus no is equal to 39 meter. Right. And 4 second, what is the distance cover in 4 second? U is 10 into 4 plus half a into 4 square. So this is 40, fine, plus 16 is equal to 56 meter. Is it clear or not? Listen one thing. If this is the 10 meter per second, fine, this is the situation when it will be 1 second. This is the situation when the body will be at 2 seconds. Is it clear or not? You tell. Yes, Vrinda. Are you getting this thing or not? You tell. Fine. Listen. It start at t is equal to 0 with initial velocity 10 meter per second and the acceleration is constant, right? So its velocity will continuously increasing, first of all, right? And after 1 second it reached to this point, after 2 second, after 3 second, 4 second. Is it clear or not? So what is the distance covered in 3 second? This is the distance covered in 3 second. What is the distance covered in 4 second? The distance covered in 4 second. You understand this expression? Right, listen one thing. Now, if it is t is equal to 0, what is this distance? Say distance cover in first second. You understand? Distance cover in first second. This is what? The distance cover in second. Is it clear? What is this? Tell me. Yes, distance cover in third second. And what is this? Fourth second. So if you want to find the distance cover in fourth second, what will you do? You have to find first the distance cover in 4 second and you have to find the distance cover in third second. So what is the total distance covered in 4 second? This. Third second is this. So what is the distance cover in? Therefore, distance covered in fourth second is nothing but S4. S4th, right? I am writing this. S4th is nothing but S4 minus S3. You understand this? Distance covered in fourth second is equal to distance covered in 4 second minus distance covered in 3 second. Right. So what is the distance covered in fourth second? We have calculated. How much it is? 56. What is the distance covered in 3 second? 39. So 56 and 39. Right. 16 में सुनो गया 7 1. This is the 17 meter. So S fourth is nothing but 17 meter. So this distance is what? Say 17 meter. Is it clear or not? So tell me. If I ask the distance covered in third second, what will you write? The distance covered in fourth second means S4 minus S3. In the same way, in third second, what will you? Yes, distance covered in 3 second minus distance travel in 2 second. Is it clear or not? Can you tell me what is the distance covered in sixth second? Fifth, in 6 second, in 5 second. This is the distance covered in sixth second, right? Is equal to nothing but distance covered in 6 second minus fifth second, in 5 seconds, sorry. You are getting this point or not? So what is the distance covered in nth second? The distance covered in nth second is nothing but distance covered in n second minus distance covered in n minus 1 second. Is it clear or not? Right. First copy this illustration, right? Then I will find the formula for the same. Any doubt I can explain once again. In the same way, the SNth, distance covered in nth second, I am writing his distance. Therefore, you may write over here distance covered in nth second, right, is nothing but Sn minus Sn minus 1. This is the distance covered in n second. This is the distance covered in n minus 1 second. Fine. You may write in the side. Listen one thing. S is equal to what? Say ut plus half at square. This is the formula. What is the distance covered in n second? Sn is nothing but initial speed is u. What is the time t? Say n second. Half a n square. Is it clear or not? You tell. What is the distance covered in n minus 1 second? What is that? U n minus 1 plus half a n minus 1 ka whole square. Is it clear or not, Vrinda? Right. So listen, Snth, therefore the Snth is nothing but Sn. What is Sn? Say u1 plus half a n square. Fine. Minus. What is Sn minus 1? Say u n minus 1 plus half a n minus 1 ka whole square. Fine. So you may write it is the u1 plus half a n square minus un minus 1 minus half a n minus 1 ka whole square. Are you getting the calculation, Vrinda? Right. Take these as a common, u1 minus un minus 1, right, and make the group of half a n square, right, minus half a n minus 1 whole square. From here you can take the u1, if you simplify u1 plus u, right, and if you take the half a common, so inside the bracket n square minus n minus 1 whole square will left. This u1 and u1 will cancel out, so only u plus half a, right. This is a square minus b square mean a plus b. Fine. Bracket a minus b bracket. A plus b, a minus b. When you will simplify, you will write this. So this is the SNF. Vrunda, this calculation is understood or not? You tell. Right. So this is the u plus half a. N plus n. This is 2n minus 1. Right. This is n and n cancel out. It is only 1. So what is the formula for the SNF? SNF formula is u plus half a 2n minus 1. This is the distance covered in nth second, where u is what? Say initial velocity. Fine. What is the a? A is nothing but the acceleration. And what is n? N is the nth second. Fine. For example, listen one thing. For this case, the distance travel in 4th second. Using this formula, we can find directly. The 4th second, what is the u? U is 10 plus, what is a? A is 2. What is the nth second? Say 2 into 4 minus 1. So this is the 10 plus 2 will cancel out, 8 minus 1, right? So 18 minus 1 is equal to 17 meter. So instead of doing this calculation, right, directly formula, we are going to use this. All right, copy this. Yes, the same thing, 7, and this is the 17 meter, right? The same answer you are getting here. So this is the formula for the distance covered in nth second. For example, if the car is supposed to be moving with 20 meter per second, right, the acceleration is supposed to 4 meter per second square. Find, right, this is that situation at t is equal. Find distance covered in, right, 5th second. Fine, distance covered in 5th second. So directly formula you can apply. How? S 5th, SNF is equal to what? U plus half a 2n minus 1. So u is what? Say 20 plus half, the acceleration is 4. What is the n? N value is over here, is the 5th. So this is the distance covered in nth second. 5th second is equal to 2 into 5 minus 1, 20 plus 2, 10 minus 1, right? 20 plus 2 into 9, right? 9 18, 38 meter is the correct answer. You understand or not? You tell, Vrunda. Right. One more thing. The important thing is that in some question, the initial velocity, if initial velocity is 0, right, then what the SNF? It is 0 plus half a 2n minus 1. So the SNF distance is nothing but half a 2n minus 1. Is it clear or not? Right. Copy this. So read this question. In this question, a particle starts from rest, that is u is equal to 0. This is the t is equal to 0, right? And the move with the constant acceleration for 15 seconds. Total seconds are 15 seconds. S1 distance covered in first 5 seconds. So this is the total distance covered in first 5 seconds. In first 5 seconds, this is the distance, right? And distance S2 in the next 10 seconds. So this is the 15 second over here. And the next 10 second, the distance cover is S2. You understand or not, you tell? Fine. So S is equal to ut plus half at square I can apply. What is the distance covered in 5 seconds? Say S1. What is the initial velocity? 0 plus acceleration is assumed to be a. The acceleration is not known. So a. And what is the time from here to here? Say 5 square. So S1 is equal to 25 by 2 into a. Is it clear or not, you tell? This is from 0 to 5 second. Now 0 to 15 second. From here to here. Right, Vanda? So again the S. No, 5 to 15 we can take, but we don't know the velocity over here. So we have to find the velocity first. It is better to choose from 0 to 15 second, and the total displacement is what? Tell me. It is S1 plus S2. Total displacement is S1 plus S2. Here the initial velocity is 0. And from here to here, what is the time? Say 15 square. Please tell. This equation is not understood or not? Tell me. Right. So this is the S1 plus S2 is equal to 225 बटे 2 into A. All right. So what is the value of A? Say 2s upon 25 value of A. We have to bring the relation between S1 and S2. So 225 upon 2. Fine. What is the value of A? 2s1 upon 50. Oh, 25. Is it clear or not? So this 2 is 2 cancel out, and this is 9 into S1 will come, because 225 upon 25 is what? Say 9. And this 2 and 2 is also cancel out. Is it clear? So 9s1 plus s2. So what is the relation? S2 is equal to 8s1. So this is the relation between S1 and S2. What is S1? The distance covered in initial 5 seconds. What is S2? Distance covered in next 10 seconds. These are the next 10 seconds. So this total displacement is what? In 15 seconds, the total displacement is what? S1 plus S2. Is it clear? Copy this. So read this question. In this question, body start from rest. It is start from rest, and 120 centimeter in 6 seconds. So the 6th second distance is equal to u plus half a 2n minus 1. I think you understand. If the u is equal to 0, I told you the distance travel, this is the in nth second. For the 6th second, 0 plus half a 2 into 6 minus 1. Is it clear or not? Tell me. What is the distance travel in 6 seconds? Say 120 centimeter. 120 centimeter mean 1.2 meter. Fine. Right. Half a into 12 minus 1. This is half a into 11. This is the 1.2. Multiply 2.4 is equal to 11 into a. So what is the acceleration? 2.4 upon 11 meter per second square is the answer. Fine. Copy this. So read this question. In this question, right, car is moving on a highway with the speed is 126 kilometer per hour. So it may be written as 5 upon 18 in meter per second. Is it clear? To convert from kilometer to meter per second, you have to multiply by 5 by 18. Right. So 6 18 and 6 दूनी 12 और 6 कम 6. Right. And 7 into 5. 7 3 ja 21, and this is 35 meter per second. So the initial speed of the car is what? 35 meter per second. Fine. And when the brakes are applied, it is stopped after some time. What the distance it covers? You will say 200 meter. Fine. So what they are asking, what is the retardation? So v square is equal to u square plus 2as. You have to apply. The final speed is what? 0. The initial speed is 35 meter per second. Acceleration is, you have to find. The distance is 200 meter. Right. So this is 35 into 35. Right. Plus 400 into a. When you will simplify, 400 into a is equal to minus 35 into 35. Minus 35 into 35 divided by 400. Right. So when you will simplify, 5 7 35 80. Right. 5 7 35 is 16. Right. Right. Yeah. 5 yes 80, and then again 5. So 7 but 16 meter per second square is the retardation. Is it clear? Right. So this is the retardation, and what they are asking, how long does it take? How long mean they are asking the time, or they may ask the distance also. So v is equal to what? U plus at. Final speed is 0. The initial speed is 35. The retardation is 49 upon a into t. Right. So when you will simplify, 49 upon 16t is equal to 35. So time is 35 into 16 upon 49. Right. You can simplify and you will get the answer in second. Right. Copy this. The answer is in second. So read this question. This is the very important and little tough question initially. Right. The engine of a train passes an electric pole with the velocity u. Suppose this is the electric pole and this is the car. Right. This is the car or the train. It is coming like this. So when it reaches to the pole, so this is the situation. Right. This is the train. This is the E4 engine, right, and this is the last compartment. So when the car or the train is reaches to this point, this is the P4 pole. Fine. What is the speed at this point? Say u. Are you getting or not? Right. The suppose, and this is the front and this is the last. So the total length of the train is assumed to be the L. Is it clear or not? If this is the engine, E4 engine, it is speed u. So listen one thing. Whether it is engine or any point, the train speed, every point will be u. You understand or not? Every point is moving with the speed u. But if the train is accelerated, so what will happen? When the train is accelerated, it is moving in this way. After some time, what will happen? The speed of the train is increased. So when the train completely passes through this pole, so this is the last compartment. So the velocity of the train become v. Is it clear or not? Suppose initially it is 10, now it become 50. When, because why it is increasing? Because it has the acceleration as question said, right? So what they are asking? They are asking when this train is crossing this pole from the mid, right? Like this, from the mid. So what is its speed? V dash. The mid mean it is L by 2. It is L by 2. So what will be the speed of the car or the train? They are asking. Is it clear or not? This speed is asked. The initial speed is u when the engine is crossing the pole. When the last compartment is crossing, the speed become v. You have to find the speed of the train when the midpoint is passing through this pole. Is it clear or not, you tell? So listen one thing. If this is the E4 engine, when it travel, initial speed is u. When it travel the complete distance L, what its speed become? Its speed become what? Say v. So what will you apply? If the acceleration is a, v square is equal to u square plus 2as. In distance s, what is s? Say v square, the u square plus 2a into L. L is the distance traveled by the engine. Is it clear or not, you tell? In this case, this is E4 engine. Initially it was over here and its velocity become v dash after traveling the distance L by 2. You understand or not? So from here, what is the initial velocity u? When it is moving, its velocity become v dash. What distance is covered? Say L by 2. So for here, v square is equal to u square, right, plus 2as. Final speed become v dash. Initial speed is what? Say u square. The acceleration is a. And what is the distance? Say L by 2. Do you understand this both two equation or not? Any doubt I can explain once again. Tell me. No, not 0. Listen, the car is this only. This is the train. it is moving like this. So when it reaches this point, its velocity become v dash. When it reaches here, velocity become v. Understood or not? This is the car. It is moving in this way. So its velocity become v dash. When it reaches this point, its velocity become v. Understood? So when it cover this distance L, its velocity become v. When it covers only L by 2 distance, so its velocity become v dash is equal to u plus 2as. What is the distance covered? Say s by 2, L by 2. Fine. Right. So we have to find the v dash while the acceleration is not known to us. From here, you may write v square minus u square is equal to 2al. From here, the v dash square, right, minus u square is equal to 2 will cancel out, a into l. Fine. You may write like this. So this is the equation number 1, equation number 2. When you will divide 1 and 2, v square minus u square upon v dash square minus u square is equal to 2al upon a into l. 2al upon al. It is cancelled, so it is 2. So we have to find the v dash. V square minus u square. Fine. 2v dash square minus 2u square. This goes this side. V square minus u square plus 2u square is equal to v square plus u square is equal to what? 2v dash square. I am writing this side. So v dash square is what? U square plus v square, right, by 2. So what is the v dash? Square root of u square plus v square by 2. So this is the velocity of the train when it crosses only the L by 2 distance. This is the L by 2. And when it crosses the L distance, its velocity become v. It is given the v dash you have to find. This is the v dash. Copy this.